Good evening, everyone. So welcome to my YouTube channel, Math Question. So today we are going to see sixth lecture on convex function. So in this lecture, we will prove the characterization of a convex function. Let f be a function defined on interval I, then f is convex if and only. So f is actually differentiable function on f is differentiable function on interval I. Okay. Then f is convex if and only if derivative of f is increasing on I. Okay. So let's see how we will prove it. So we'll use previous lecture number 5. Okay. So if you do not have a knowledge of that lecture, please see that lecture on YouTube. First, assume that f is convex. Okay. Convex. Then for any x belongs to I, x is greater than a, we have okay. So let A and B belongs to I. A is scalar than B. Then for any x belongs to I, in this way we have fx minus fa upon x minus a is less than fb minus fa upon b minus a. F f fb minus fx upon b minus f. Okay. Now taking this part, this implies fx minus fa upon x minus a less than fb minus fa upon b minus a for all x such that x in this range. Now, so this will imply limit x tends to a plus fx minus fa upon x minus a will be less than fb minus fa upon b minus a. So what is this? This is because function is differentiable. This is f dash a. fb fa upon b minus a. So let's say this equation here. Now again using this part. Now we will use this part. Okay. So and what we have also we have this one fb minus fa upon b minus a is fb minus fx upon b minus x for all x belongs to I such that, okay, so this implies fb minus fj b minus a limit x tends to b from right left, x tends to b minus fb minus fx upon b minus x. So what is this function is differentiable. So this is nothing but f dash b. So this implies fb minus fj upon b minus a is less than. Okay. So from 1 and 2, we have f dash a less than f b minus f a upon b minus a that is less than f dash b. Okay. So, so now taking this one, so this implies f dash a is less than f dash for all a b belongs to I. Okay. So what is the meaning of this? This implies f dash is increasing on I. Okay. And now conversely assume that now we will prove converse part. Conversely assume that f dash is increasing on I. Okay. Let x1, x2 belongs to I such that x1 is less than x2. Okay. Okay. Now take T belongs to open interval 0, 1. Then x xt is equal to T x1 plus 1 minus T x2 belongs to I with x1 less than xt. Okay. Now, by mean value theorem, there exists C1 and C2 belongs to I with x1 such that f x p minus f x is equal to f dash c1, okay, f3 minus f3, okay, that is equal to, put the value of xt, then it will be 1 minus t f dash c1, okay, okay, 1 minus t. So when we will put value of xt, so that is 1 minus x1, 1 minus t. So it will be x2 minus x1, x2 minus x1. Okay. And what is f xt minus f x2? This is f dash t2. Okay. xt minus x2. So what will be this? Put the value of xt. So this will be t f dash t2. Okay. F dash x1 minus x2. x1 minus x1 minus x2. Okay. x1 minus x. So how this can be written as? So if I take x2 here, we change here, you write here. So this is uh, x2 minus x3. This is uh, x2 minus x3. Then this will be equal to t x2 minus x1. Okay. We put x1 t x1. Okay. And x2 yes here. So this is this. So let's say 3 and 4. Now multiplying in 3 by t and in 4 by 1 minus t. We get what we get. So this will be t f x t minus f x1 is t 1 minus t f dash t1 x2 minus x1. This is 5 and 1 minus t f x2 minus f x1 f t, that is t 1 minus t f dash t2 f2 minus, let's take this expression. Okay. Now we have this one. this implies C1 is less than C2. So this implies f dash C1 less than f dash C2 because f dash is increasing. If this is increasing, so this will imply T1 minus T f dash T1 x2 minus x1 will be less than f dash T1 minus T f dash T2 x2 minus x1 because P lies in this range and 1 minus P also lies in there and x2 minus x1 is also greater than 0. So we have this. So from so we have what is this? What is left hand side from 5? This is nothing but P f f t minus f x1. Okay. And what is this 1 minus P f x2 minus f x3 from 5 and 6. Now we will solve it. Solve it. So what is this P f x3 minus f t f x1 that is less than 1 minus P of x2 and this is then plus f x3 minus P of x3. So this is plus, okay? This is plus and this is minus, okay? So this and this cancel out, okay? So we have f x3 less than P f x1 plus 1 minus P f x2. So this implies f t, put the value of x3, 1 minus P x3 that is less than P f x1 plus 1 minus P f x2. We have this one for all P and x1, x2 belongs to I, x1 is less than x2. So what is the meaning of this? The meaning of this is f is convex on I. So this implies f is convex on I. So this result is true. Okay. We have also done converse part. So today's lecture up to this. If you have any problem related to this, you can comment on my YouTube channel. Like, share, comment and subscribe my YouTube channel. So thank you very much for today's lecture. Thank you. We will see you for next lecture.